Hi, Roselle. Okay, I got your emails and they're coming through fine. So I think you were asking me how to rearrange this area formula like we did last night. And first of all, you don't need to. It was just to sort of save you time in your calculations and to make it a little bit more elegant. But if you want to leave it the way it is and you understand it that way, it's fine to leave it like that is. I think he'll be pretty impressed that you came up with that at all. Anyway, if you do want to do it, I'll just go through it real quickly here again and explain it for you. Okay. So what I would do with this is keep your 4 minus pi, of course, for your first term. And then for your sum, this 2 squared, because everything's multiplied in this bracket, you can square both things, right? So if I put 1/4 to the n and I square it, then it makes it 1/4 to the 2n. You just multiply the exponents there. And if I take 2 to the 2, then that's going to be times 4. Okay. And then pi times, again, 2 times n, so 1/4 to the 2n. And then times that by 3 to the n minus 3 to the n minus 1 times 4, okay? So if we have all that, then are we missing a pi here? I thought we took out a 4 minus pi, but maybe that was for the perimeter one? I can't remember. Okay, let's look and see what we have here. We have 4 in both cases. So in our sum, this is plus n equals 1 to infinity. The equals 1 got cut off there. All right, so we have 4 times 1 over 4 to the 2n minus 4 pi times 1 over 4 to the 2n times 3 to the n minus 1. So if we're looking for common factors in the summation part of this, we've got a common factor of 4, and we have a common factor of this 1/4 to the 2n. So we could write that as 4 times 1 over 4 to the 2n times 1 minus 4 pi, no, 1 minus pi. I used the 4 already. Okay. Times 3 to the n minus 1. And then I think what we said was, I'm having a hard time remembering what we said. I think what we said was that then we could bring the 4 and the 1 minus pi out of the summation and put it in front, and then just add up all of the ones with the n. So I think what we did was we did 4 minus 4 pi. And took that out as a common factor. And then what we would have left would be the 1 over 4 to the 2n times the 3 to the n minus 1 each time. And so that would be a way to simplify it so that you just had these terms to work with every time that you increase your value of n. I think that's probably the most simplified form that you would want to use there. And then just start setting in values of 1, 2, 3, 4, 5 until you see where it's going. You're going to start to approach 0 really quickly. And when those values start to approach 0, then you can determine what the limit is approaching. If you want to, like when you've got it worked out, if you want to send it to me to look over, I'd be happy to do that and check it over for you before it goes in on Monday. I'm going to be out of town tonight until tomorrow night, but I can certainly look at it on Sunday for you. Okay, have a good weekend.